Oops, hello grade 11 people. Okay, today's lesson is ion concentration. Okay, so we'll just get into it here. So number one, what is an ion? What is an ion? An ion is known as a charged atom. So it's anytime that you have an atom with a charge. So we write these all the time. So for example, chlorine minus, that's an ion. Or oxygen 2 minus, barium 2 plus, etc. Right? Now the only thing, make sure you're writing the number first and then the sign, right? Otherwise it's an oxidation state, not the ionic charge. So an ion, keep in mind as we work through this lesson, it's just a charged atom. Okay, we're gonna learn how to do this basically just by going through the examples. So the kind of question you'll see here is find the concentration of chlorine ions in a 2.0 molar aluminum chloride solution. Note we use square brackets to indicate concentration. So I'm just going to show you that right away. So for example, we're looking for chlorine ions here. So a concentration of chlorine ions, and by square brackets, that is what I mean. So we put them in square brackets. If I asked you to find the concentration of the aluminum ions, it would be aluminum 3 plus in square brackets. So these square brackets, that indicates that you're talking about concentration, and you'll use that a lot in grade 12. Okay, so when we do these kinds of questions, so you've got aluminum chloride. So your first step, you need to know that this is going to be AlCl3. So you need to be able to know what the ionic charge is, know how they bond together. Now, aluminum chloride, you know what the concentration is of that. It's 2.0 molar, but I'm asking you specifically for the Cl minus concentration. So your first step when you do these is going to be to write the dissociation equation. So we've got aluminum chloride. I'm going to put it in the solid state. We did this already. We wrote dissociation equations. So when they break apart, they're going to form the ions, right? So aluminum 3 plus 3Cl minus. And I know it's 3Cl minus because I have to balance it, and I kind of jumped ahead on that one. So this would be my dissociation equation here. So this is step one. Okay, so step two, I just recopied the equation here so we'd have it. Use dimensional analysis and the mole ratio to solve. I'm just going to go back because I don't remember what the information was. Okay, it's 2 molar aluminum chloride. That's right. So 2.0 molar, that's what you know. You are asked to find the concentration of the Cl minus. Okay, so we're going to use dA, and we're going to use the mole ratio to find this. So I'm going to use the square brackets. So Cl minus, the concentration of Cl minus, dA, as always, you're going to write down what you know. I know that we've got 2.0. Now, molarity, the unit for that, moles per liter, right? So I'm going to specifically write it like this so that you can see units cancel. And it's the moles of aluminum chloride, per liter. Now, in your conversion ratio here, Cl minus is going to go on top. So this would be mole Cl minus. This is my mole ratio here. Moles aluminum chloride goes on the bottom, and that's because the diagonal units, as always, these are always the same, right? So now, what is the ratio between chlorine ions and aluminum chloride? And I look back to my, I'm going to switch colors. Look back to my balanced equation here, and it's 3 to 1, right? So I'm going to have a 3 to 1 there. Then I can just work it out. And of course, 3 times 2 is 6.0. Make sure you check your sig figs. Moles per liter. So what this means is that you've got 6 moles per liter of chlorine ions in a 2 molar solution of aluminum chloride. Okay, so you just use the mole ratio to solve these. Okay, let's do another one. All right. What is the concentration of iron 3 plus in 0.25 liters of 2 molar iron 3 sulfide? So this question, if we were in class, I wouldn't say anything to you and I would let you all answer it and most of you would get it wrong, which, as you all know, that's one of my favorite things to do. Um, so, but fortunately we can't do that now. So is this piece of information important? Does it matter? So if you look back, I'm just going to flip back here. If you look back at this question here, we were not given a volume here. We were just given the concentration. There was no volume there, and we solved it. This question, I gave you a volume. That volume is just there to mislead you. It really has nothing to do with the math here. You don't need it. And I'll get you to look at here. I'm really bent on this Kool-Aid and how I was never allowed to have it as a child. So Kool-Aid is in this bottle here, and we talked about it the other day about how color is a good indicator of concentration, right? And as the color becomes more saturated, that means it's more concentrated. When the color becomes faded, that would mean it's the other side, it's becoming diluted. Now, if you look at these, this is the original bottle, right? Obviously, we've got a larger volume there, and then someone's poured, some mother has, who allows their children to have it, has poured some Kool-Aid into this glass. And are the colors different? No, the colors are the same. Therefore, the concentrations in both of these, in this glass and in this bottle, the two concentrations are exactly the same, even though the volumes are different. So always remember that. Concentration is just a ratio of the moles of the solute to the liters of the solution. So it doesn't matter how much you have. The concentrations can be equal. So, long story short, you don't need this. Okay, so let's solve it then. So we've got Fe3 plus. So first of all, we're going to write our dissociation equation. That's going to be our first step. So I've got Fe2S3 breaking apart into iron 3 plus sulfur 2 minus. Oh, I should have my aqueous. And then I need to balance it, right? So if I look here, I'm going to need 2 here and a 3 here. Now it's all balanced. I know that I've got 2.0 moles per liter of the iron sulfide, and the question is asking you, what is the concentration of the iron ions? So what you're going to do, you are looking for Fe3 plus equals, you write down what you know, 2.0 moles per liter. Oh shoot, I wrote that wrong. Let's do it this way. Moles per liter. Oh, I forgot to hold on. I'm going to go back. I screwed up. Sorry, guys. I meant to tell you this before. So if you look here, the moles moles aluminum chloride, and you're left with moles of chlorine over liters. So that is where this unit comes from, and that's why I wrote it like that, so you could see it a little easier. Sorry. So we go back here. So I've got the iron sulfide in 1 liter. Now I'm going to write my mole ratio. So I've got moles of Fe2S3 on the bottom, moles of the iron 3 plus. Don't forget to put the charges. If you don't have the charges, it's not correct, right? And now what's the ratio between them? And I get this from the balanced equation here. So I've got 2 to 1 here. So 2 to 1. And now I'm just going to show you how my units cancel. Hold on. Let's use orange. So the moles of Fe2S3, moles of Fe2S3, and I'm left in moles of iron per liter, which is what I want, moles per liter. And so my answer then, check for sig figs, of course, 4.0 moles per liter. And that will be the concentration of the Fe3 plus. Okay, your assignment. Did you like this little futuristic diagram? I thought it was very chemistry-esque. Your assignment is going to be exercise 48. So you've got the answers, they're already on there, so take a look at that, and then you can message me or ask me if you have any questions. Great. Thanks, guys.